Hello, everyone, and welcome back to our lecture. The first service that I want to cover is the AWS Codebuild service. And this is a managed continuous integration service provided by AWS. It allows you to build your code, to compile your code, run unit tests, run your linting tests, and ultimately create a set of output artifacts, which could be like the compiled binary version of your application. The beauty of Codebuild is that AWS will provide you with everything that you need to create the output artifact. There's no need for you to provision any sort of like EC2 instances or manage the configuration of build servers. All of the build environments are provided for you automatically using Codebuild. And it can scale to meet the needs of your team, whether you are a team of one or if you have hundreds of developers in your organization. Codebuild can support all of your development needs and all of your build needs. Codebuild will provide you with essentially sort of like prepackaged environments that you can use to build your application code. And these could be like Java or Python, Ruby environments. That you could use it to build your Android applications, your .NET applications. There are a wide variety of different prepackaged environments that are available. And if one of these environments doesn't meet your needs, then you can always go and create a custom environment for Codebuild. In terms of billing, the Codebuild service is billed by the minute. So every minute it takes to run your build, you will get charged for by AWS. And there is a free tier available for the Codebuild service. You can run a small build instance, what's called a build.general1.small instance type. You can run that for up to 100 minutes each month as part of the free tier. The exercises that we will do in this class are only consume maybe a minute of build time. So you should stay well within the free tier that's available. And just to kind of level set things once again, what is the Codebuild service providing? The Codebuild service is really focused on that initial continuous integration part of the pipeline where a developer has committed their code to a repository like GitHub or Code Commit, and then that will automatically trigger a build of their application code. And during that build process, an actual environment is launched by the Codebuild service. And that environment, has an operating system, it has an application framework, libraries all already installed on it and build tooling. And once that application environment has been launched, the build server will essentially clone that Git repository and then leverage the build tooling to actually build your application code. The application code, once it's been built, will be pushed out to a code repository, which oftentimes with Codebuild, you will use something like S3 as the code artifact repository. So how does the Codebuild service work? Well, it starts, you start by defining what's called a build project. And the build project describes how to actually run a build. It will define where the source code is located, like whether it's located in GitHub or in Code Commit or maybe even an S3 bucket. The build project will define what sort of build environment to use, and it will also describe a set of build commands to run to actually generate a build. And the build commands that you run will depend on, what type of application you're building, whether you're building a Java application or C# or Python or, whatever the case may be. And then the build project will also specify where to store the build output artifacts. Maybe it's something like an S3 bucket. Well, so as part of the build project, you are specifying a build environment. And the build environment kind of consists of three different things. There's an operating system, which could be Linux or Windows. There's a programming language runtime, which is, think of this as being like you have Java, software development kit installed on the system, or Python interpreter, or maybe you have Ruby installed on the build environment. These are the things that are required to actually build your application. And then finally, you have some tools that may be installed. And so like you might have something like Maven installed as a sort of make tool for building a Java application. So during that build process, then the build environment is going to be created, the source code is downloaded into the build environment, and then a set of commands are executed to actually build the application code. The result of those build commands is hopefully a build artifact, which is then stored and pushed up, uploaded into something like an S3 bucket. The build project and this process is supported by what we call a build specification. And the build specification will define the set of commands that the code build environment will use to actually run the build. The build specification is defined within a YAML file called the build spec file. It's a build spec.yaml. And that is typically located within the root directory of your source code repository. You can imagine like you're building your application code, and of course you're committing that application code into a Git repository. At the root of that Git repository, the root of your application code directory, you create a build spec.yaml file. And in that build spec.yaml file, you define all of the commands that are required to actually build your application code. The cool thing about the build spec YAML file is that it lives right alongside of your application code in the exact same code repository. When Codebuild creates an environment and downloads and clones your repository, it will look for this build spec.yaml file at the root of your repository, and then it will use the commands in that file to actually build your application. This is an example of what the build spec.yaml file looks like. It's a YAML file with key values, and there are a few different sections that you can define within the file. There's a version, an environment, phases, and an artifacts section in the file. And let's take a look at each one of these sections in more detail. Every build spec.yaml file has to start with a version. And at the time that this video was recorded, the current build spec version is 0.2. So at the very top of your YAML file, you're going to start with a version. Below that, you can define environment variables. And these are optional. You don't have to set them, but there are many cases where it's advantageous to set environment variables during the build process. Your build tooling oftentimes will look for specific environment variables to pull out values that are required during the build process. And so you can create an environment in env section and then have a list of variables that you define, each of which has a key and then a specified value. The next section is the phases section. And this is really sort of the core part of the build spec.yaml file. And this is where you define the different sort of stages of the build process. And there are 4 different phases which you can define in a build spec.yaml file. There's an install phase, and during the install phase, that's typically where you define the sort of runtime packages that need to be installed into the build environment. So for example, you might install Java and the OpenJDK 8 version of Java during the install phase. There's the pre-build phase, and oftentimes in the pre-build phase, you will run commands to install certain dependencies. For example, if you were building a Node.js application, you would want to install all of the application dependencies, the Node dependencies. If you were building a Python application, this is where you might do like a pip install of all of the dependencies that are specified in the requirements.txt file. The third phase is the build phase, and that's where you would put the actual commands that are required to run a build. And these commands are, essentially shell commands. They are like bash shell commands that we have seen earlier throughout the course. And the commands that you use would be completely dependent on the type of application that you're building. If you're building a Java application, you might do something like a maven install command to kick off a build. The final stage or phase that you can specify is the post-build phase. And that's where you would specify commands that should run after the build process. And so you might want to package up the resulting output files into something like a WAR file or maybe even a zip file. And it's that zip file that would that's sort of like your packaged output artifact that you would ultimately then push to an S3 bucket. The commands that you run during the build process are just like, shell script commands. And if any one of those commands fail, then the build process itself will fail. And the code build service will report that there's been a build failure. As part of the build stage, you can also add a finally block of commands. And in the finally block, you can specify commands that will always run in the build environment, even if any of the preceding build commands fail. So in the finally block, you might need to do something to sort of do some cleanup work. If a build fails, or even if it doesn't, so those commands will always run no matter if any of the build commands fail. Here are some examples of runtime application environments and libraries that are available to you. And you specify these in the build spec.yaml file. For example, if you want to build a Java application, then you can specify whether you want to use Java JDK 8 or Java JDK 11. If you're doing like a Python application, you can specify Python 3.7. And this list is always expanding. You can go and look at the documentation that's available. Again, these are prepackaged build environments that are made available to you by AWS. If you want to create your own environment with your own custom set of software versions and so on, you can feel free to do so. That's something that you can build, and there are instructions and AWS documentation describing how to build your own custom build environment. The last section of the build spec.yaml file is the artifacts section. And this section describes where those output artifacts are going to be stored. And then you can also optionally specify the name of the output artifact when it's stored in the artifact repository. So you can actually sort of rename the output artifact when it's stored in the repository if you want to. Generally, we're storing these output artifacts in an S3 bucket when we're using the Codebuild service. And in the example here in this slide, we're defining an artifacts section. We have a set of files. In this case, there's just one file that we are specifying as an output artifact. It's located in the target subdirectory, which is a subdirectory within our application directory. And we're specifying an output artifact called myapp.jar, a Java application file. This then is going to be stored in an S3 bucket, and it's going to be renamed. And we are actually using a little bit of shell code magic to rename the file. You can see the $ parentheses, and we're running the date command. That is basically going to, when the file is stored in the S3 bucket, it's going to rename that file myapp.jar dash, and then a date stamp, which is going to be the year, month, and day. And that's pretty common to sort of version, not only just version our files, but when we store them in an artifact repository, we would rename the file and insert some sort of date timestamp into the file name, just so we can sort of quickly see when that file was created. And it's also a way to guarantee that the output artifact is going to be in a unique file within the artifact repository.